we've got a really diverse kind of group of talks today, a lot focusing on the kind of the data space. There's kind of a few archetypes of tech talks, the library talk, et cetera. This is something else. Maybe let's say it's an opinionated survey, and maybe something of an intervention. I hoped to have a little bit more, let's say, any code to release with this, but I don't have that. So instead of the release of a library, it's maybe the announcement of some kind of program to come within the Scala community. Yeah, but great talks also today. So the theme is really going to be Scala as an environment for statistical programming, both to say perhaps that this is really possible, and also to kind of inquire into how how much it's able to compete with things like R and Python. So a little bit about me. I do live in New York right now, but I went to school here in Portland and worked here for a while. I studied mathematics and CS, so I kind of straddle the line between doing a lot of functional programming and kind of formal verification on one hand, and let's say data science, kind of assuming this refers to some real thing that we know what it is. And so, yeah, I did all this kind of work. And I started working on mostly kind of in R and Python on the data science end. Starting out a kind of big citation network analysis of the US patents. I did some stuff in Perl, doing like news analytics, and then worked in Scala here in Portland doing kind of medical fraud and visualization. So I've worked in a lot of these different I've done data science for most of my career, and I was working in these kind of hodgepodge of languages. And yeah, so mostly R and Python to begin with, but it was really the Scala where I was really hoping that I could find this way to kind of unify this, a really nice modern language which we could potentially do some serious analytics. And so I was utterly sold on this language. And one of the first things I wanted to do was just kind of re-implement this simple data munging kind of job that I did in Python. And I was just horrified at how it turned out. Like this, the memory usage was 3 or 4 times more. I mean, just figuring out how to parse a file was just, awful, right? We have this source thing that it represents source files. It's just obvious that it's not what the language is designed for at this point, this kind of brute kind of scripting tasks or something, right? And I'm not really, I'm not coming from a Java background, so all this kind of Java file stuff at the time was just kind of horrible. And so, okay, then we have this data maybe in a nice case class, we have it in Scala, and what are we going to do with it, right? There's not much at all in Scala at the time, and then we have this Weka thing, which is really about as elegant as its namesake. That's a Weka, in case no one knew. That's not a nice creature. And then we have all these things, like, all the things that people have been talking about today, right? The boxing, numeric types in Scala or in Java are just crazy. We have non-commutative addition on numeric types, right? It's insane. What can we do log on? Yeah, who knows? How do we do log? It's different between numeric types. This is just not a nice way to do data science, right? So I beat a retreat, right? I love Scala for this kind of core web and systems development, but it just didn't have what it took for this kind of general workflow of data analytics. So I stuck to kind of doing this data munging in Python and analytics and visualization in R. So it's kind of polyglot workflow, which it has its obvious trademarks. So I'm talking about this workflow, and I'm sure this will be pretty familiar to people. What is it, right? And it's important, especially to emphasize that I am talking about like data science, which is to say that not someone who has a degree in like a particular domain of data, but one for whom this kind of experimental status is really important, right? Like we're working in areas where you might not have very many kind of a priori assumptions about how it's structured. And so really kind of playing with this is important, right? And so first, we're kind of munging this data maybe from a variety of APIs, CSV files, binary protocols, XML files. Maybe we're lucky and have some really nice process database. We're gonna have to do a lot of exploration, right? We're gonna be kind of sorting, filtering, manipulating this data set, doing some kind of rudimentary statistical analyses, visualizations, and then sometime we'll have a problem that maybe we understand, and we'll be able to build a model for it on some structure and features of the data that hopefully we can kind of bind as lately as possible when we really understand what's going on in whatever domain. And then somehow production happens. It's great, right? So in short, what do you need for this, right? We need an interactive environment that promotes code reuse, right? I mean, you don't want this kind of repo where things get lost. You want to be able to kind of take code that you've developed in this experimental way and use. You need a really good data structure for exploring, subsetting, transforming heterogeneously typed columnar data. I'll go into this a bit more because this is maybe the least obvious of these points, or more debatable. You need sensible numeric abstractions so you can write just generic code on numbers with sensible trade-offs between precision and performance. You need access to a decent library for easily and variously visualizing this data structure. And we just need a standard statistical library of well-tested and performant methods and models. Right? This is just what you need. And so on this point too, I will harp on this a little bit. I think this spreadsheet or the frame is just this fundamental way that we have right now to work with data. Whether it's these kind of row types or kind of relational algebra, this is just what we have. And it's important to distinguish it from the matrix, right? Because it's not just numeric data. It's fundamentally heterogeneously typed. It's exploratory phase. We have categorical variables, dates, whatever. Arbitrary string, who knows, and it's indexed, right? And there's some extent to which this is kind of historically contingent based on the kind of prevalence of Excel, but it is really natural for exploratory work. And it's especially great when one wants the composability of one's statistical libraries, who wants to be able to chain together statistical transformations and then pipe it into a visualization at the end, right? This is kind of the generic form we have. And again, exploration. So Hadley Wickham, who's probably done the most work, like really on these, the whole kind of environment phase, matching together kind of our models and our visualization, has a nice paper out recently called Tidy Data. And he has this I think is a really, maybe obvious, but it's a kind of important point, right? A tidy data set is easy to manipulate, model, and visualize, and it has a very specific structure. Variables are stored in columns, observations in rows, and a single type of experimental unit per data set. And I think really an environment for statistical computing just kind of has to support this, or it ends up being just awful. Obviously these are like some pretty basic criteria that are met by just an ever-increasing number of languages and frameworks, right? I mean, for any language, there exists at least one book of the form X for data Y, right? Data munging, data science, data analysis, data sorcery. We have all these libraries and even new languages that are developed just to tackle like this core workflow. So I think it's important here that we kind of really work to be able to assess languages along this kind of really dangerous border between the objective, let's say, what tools exist, how mature they are, history of error and correction within it, and this kind of like subjective criteria of just what is it like to work with this, and really trying to kind of straddle this line. Because I mean, we have this real problem of how one chooses between these that isn't just based on the existence of some kind of legacy code base that we're stuck with, right? So this is a really hard problem. Here we have some nice Jagster quotes. Maybe we can't read this on here, but it's just this basic point that in computer science and mathematics, notational conventions are just crucial, right? Our achievements depend critically on the availability of this. And whereas mathematicians can kind of say some formalism and then natural language, kind of assuming some kind of level of meaning that pre-exists, we as computer scientists are 100% stuck in the program text, like with all the idiosyncrasies of the APIs, all these inconsistencies. This is all we have, right? And it's really hard to say anything sensible whatsoever about this, right? And Jagster, gets really dramatic here, right? It's his final hope before he dies. He hopes to understand, one formal notation why it's good and why another's just a pain in the neck, right? And he didn't really make it there, right? I mean, computer science is still like 99% cargo science, like just cargo cult stuff, right? We don't have it yet, so we're working on this. And so I'm kind of proposing, something like, let's say, a phenomenology of the data scientist. That we really need to work with these kind of tools and environments to assess the kind of experience that we're providing for people. And I think we're more prone to do this with APIs than languages that seem to get more assessed based on kind of feature sets and really what it's like to kind of be in the nitty-gritty of this. And often I guess it is because we are stuck with a language depending on some kind of niche domain that we're in or legacy code base. But I also think it's much more important because languages, even formal, are much more mediums than tools, right? And I think it's especially important in this realm of data science because, whereas I don't need Twitter to talk to my friend or something or Instagram to see pictures of them, we really don't have any way to work with data but computers, right? And we see this, Excel is this hugely important piece of software that has changed the world due to its deficiencies, right? I mean, we have this unversion controlled, highly mutable, completely unsafe, but beautiful and perfect window on the data. I don't know, it's insane, right? So it is this important problem, I think, that we as computer scientists kind of owe it to try and get better. And so I was inspired after Paul's talk to put in a slide of some Wittgensteinian corollaries. The limit to my language limits my world, but also the world of the happy is quite different from the world of the unhappy, and I cannot bend the happenings of the world to my will. I am completely powerless. So I really want to understand the difference between the happy world of the data scientist and the world of the unhappiness, and the way that these languages and environments kind of constrain us within here. Okay, so let's just talk about some criteria. And I think this is not, these criteria, we're kind of stumbled back down to the abyss of article. I'm trying to straddle this line, but it's hard. These are not categories worth the name of extra, but I think this is the start of these things that we can think about that are relatively concrete, right? We want to talk about predictable and concise APIs, the consistency of data structured inputs and outputs into our libraries, how easy it is to reason about it, the performance, correctness, and it just kind of works there. I guess that's so today, we're going to take a long time. We won't talk about these other tools. We're going to kind of focus in on R, Python, these are the main kind of libraries, and Scala, whether or not it can really serve along this criteria as an environment for doing statistical computing. So Python, if you've done work here, we have this obviously dynamic language with a nice REPL, an interactive workflow via IPython with these kind of great web tools. We have Pandas, which provides a nice frame structure, relatively sane numeric types with pretty good performance via NumPy. Visualization is pretty weak, and we do have a pretty good collection of kind of fundamental statistical tools. And I think what you see is that internal to any specific library, APIs are pretty consistent and have a high degree of functionality. But what you immediately experience doing a lot of data stuff in Python is that it's just not structured from the ground up on analytics, right? I mean, this Pandas structure is not what's feeding into all these other tools. You have these kind of islands of libraries that are very well done. It is a nice language for doing data science, but you also just don't have the ability at the language level to correct this, right? You don't have the power to build these enforceable abstractions. You don't have these types to really remedy these kind of different structures. So you're left kind of doing all this kind of ad hoc, arbitrary array manipulation just to get things structured, to feed it into a visualization library or move it around. And this is just not ideal. And so with R, similarly with this dynamic language with a nice interactive environment, and we have this frame structure that is very nice and is the root of the language, really. Consistent numeric abstraction, beautiful modern visualization tools like ggplot, and every statistical method that has ever been conceived, has at least 5 implementations, which is just good. And it's just this insane language, right? It's APL and scheme. What is this? It's insane. But it's kind of nice, right? We have macros, lazy evaluation, first-class functions. We can make this nice DSL for doing regressions, and the data set is lazily evaluated. It's R. And all these things are structured on this frame. We have the frame which does exist kind of at the core of the language. We assume that we have a visualization library. Maybe we manipulate it a bit, but it accepts this frame. We have statistical methods that accept this frame. It's nice. And Hadley Wickham has been doing a lot of really good work to kind of make this even more consistent. But at the root, it's just, things like we use grep to find an element in a list, weird assignment things. I've never understood actually how to get things out of frames, and I've used it for a long time. It might be my fault. ggplot 2 is really nice, but it's this kind of ad hoc API with addition that's definitely not commutative, right? Kind of link these things together and beauty emerges. It's kind of nice. But then all this academic abandonware and things just don't work. It's just it's unified, but it's just not, it's a crazy language that makes it difficult to write good code, let's say. We don't have this consistency across projects. So I mean, we see this as a pattern, right? It's these insanely inconsistent, unpredictable APIs. Things are difficult to reason about. Performance is generally not very good. And we still have tools for building systems in the large, right? I mean, I guess people do make real products in dynamic languages, but it's difficult, especially in R, right? Python systems. So, I mean, this is the functional programming conference, particularly Scala. We should be ready to kind of leap forward here, right? I mean, functional programming should be the eradication of all this arbitrariness, introduction of compile time errors, and its beautiful compile time optimizations for whatever runtime environments, distributed, graphic, whatever. We've seen today all these kind of beautiful numeric abstractions from higher mathematics that our languages can actually express and enforce. And at the same time, we should also be able to have the flexibility of R and Python. I mean, there's just no reason that we can't. We have this nice repo, we have nice tools. I mean, Scala really should be a first-class contender in this. There's just no reason for it not to be, right? I mean, I'm sure everyone saw this XKCD recently, right? I mean, functional programming combines the flexibility and power of abstract mathematics with the intuitive clarity of abstract mathematics. And maybe that's bad if you're not doing abstract mathematics, but if you're doing abstract mathematics, like, you should be doing functional programming. I think that's just the basic point of it. So I think we should obviously be Java here, and I think we should be able to provide the flexibility people actually need from a language like R and Python. I mean, again, like Paul Phillips said, right? I mean, freedom is slavery or whatever, but I think we can provide what is actually needed in this case, but also provide these sensible, uniform abstractions and correctness. And so what do we see today, right? Scala has changed a lot since 2.8, right? I mean, a lot has come up. We have all these different tools. We have Saddle, Spire, Breeze, Scala NLP, we have Scala Notebook, and Algebra. Right? We've heard about a lot of these today. And this is to say that we have a frame structure with a full API modeled after, in fact, developed by one of the founders of Pandas. We have performant numeric abstractions for generic programming. We have this great NLP and ML library with performant matrix vector data structure and linear algebra tools. We have this great improvement on the REPL with that really promotes the kind of reproducibility and reuse of code, collaboration, and we can do some visualization with D3. And then Algebra, which is also letting us kind of really leverage these abstractions also for distributed analytics, right? So we should have a lot of the groundwork done to provide this really nice environment. Okay, so we've seen Spire a lot today. It's terrific, it's really hands off. It's absolutely great for providing these core numeric abstractions that should be able to be reused across all these other libraries. Like I am working, I don't know how much we'll be able to be open sourced on a visualization library right now, and Spire has just been outstanding and able to make these kind of statistical methods that you want in visualization. They can work at both big decimal and double. It's just something you want. If you want to scale data before and after it's in your kind of visualization domain, which has to be doubles, right? And even if it's just for providing a kind of uniform standard library of numbers atop of all of Java's kind of numeric types, it's just an outstanding step forward. But we'll have more talk about Spire today. And Saddle is a really great first step towards a frame structure in Scala, which I think is really important. I think there's some things where this can be some kind of inconsistent APIs, just in terms of the naming convention, which is absolutely minor. The thing that I've been harping on a lot today and that I think should be addressed is the heterogeneously typed case, because I don't think that's a place where Saddle really is the best, because its basic type is the row index type, the column index type, and the value type. And so if you're doing a heterogeneous, we're left with the value type of any. They provide you with methods for kind of subsetting a specific type T of your frame. But I don't think that's quite as good for this kind of experimental workflow where you're doing lots of sorting and stuff. And this isn't, we have the fact that in Scala we don't really have good record types, right? I mean, how would an AV wall type this, right? And so I think one reason I've really tried to harp on this point is that I think we do kind of now have a way that this can be done, which is to say we have shapeless. And I think that there's I'm hoping to put forth this argument that this would be a really great use case for shapeless. I think it's something that's really important for Scala, and I think it would be a way to really showcase this library in a way that could have good traction, right? We could actually have this strongly typed heterogeneous columns. And it's really interesting. It's something I'm currently experimenting with. And also, it doesn't support big decimal out of the box, which isn't a huge deal because it's easy to add, but it's you do have this problem that it's working with the kind of core Java examples, and you have these kind of idiosyncrasies. Scala NLP, which was formerly known as Scala, is a really great tool for doing these core linear algebraic tasks, and a great core library for statistical methods. And it's focused on the NLP side of it, but it's a little focused on the NLP side of things. It's not the most full featured in terms of kind of a lot of the things you would want, but it's really, this is particularly interesting because it is coming out of Stanford and a lot of these NLP communities here, so we're really kind of starting to see various research communities take on Scala, and a lot of them are building on top of the stuff that they're using, like this, not Scala, but Breeze tools. Like we have Scalabha, I've never said that one out loud, that UT Austin is making. The University of Maryland is also doing a lot of this stuff. Stanford's also put up a topic modeling toolkit. I mean, you have lots of really pretty great research tools that are now being done in Scala, because one of these big difficulties to overcome is just that all the research has been done here and will be done here, so getting this kind of momentum to shift is really huge. And I think the more that we kind of, as a community, work on this environment, the more that this will continue to happen. Then we have Scala Notebook, which I think Nathan Hamler's done some really great presentations on. I recommend that people to watch those online. It's really improved the REPL with kind of modern web tools. You can, any method that outputs this kind of HTML structure will be visualized immediately. Great interactive tools. It's really nice. It does need some more work on usability, I think. It's a little bit difficult at present to just kind of start up a new project. You have to kind of incorporate it into your SBT build in less than ideal way. You can't just say, work with this project. It's okay, so we have all these really nice things. And what I want to stress here is that I think that we need to really think about this, the coming together of these different tools, because they are all a bit disparate, right? I mean, so one thing immediately, we don't really have any modern scene visualization tools in Scala, especially one that operates on any of these kind of core data structures of the libraries. Almost everything works with doubles, or they've done all this hard-coded specialization. I think we really need to work on this heterogeneously typed saddle frame, possibly using shapeless. And I think what I really want to stress is that I think that each of these things has a really well-defined domain. And I want to stress that things try to stick to doing one thing and doing it really well and outsourcing the rest to these other libraries. I think the Spire's been working towards a linear algebra library now. Breeze has its own abstract algebraic type, so does Algebird. Saddle is reproducing all of the matrix operations that Breeze has done. And then especially, we see everyone has gone through the horrors of doing all this specialization logic in their libraries, which is really hard to get right. And it's crucial to rely on. So I think really the more that we can kind of separate out these domains of abstraction, I think we can do really well and really create this thing, because the bar is really, really, really low. We could probably use some more reallys in there, because it's just abysmal, right? I mean, and I think we have the groundwork and momentum in Scala for doing data analytics is pretty huge. I mean, most places that use Scala these days are doing it for big data analytics, right? I mean, Spark just got $15 million from Anderson Horowitz. I mean, so I think there is this huge amount of momentum, and I think we really have the library here. It's not like we're starting from scratch. I think we have these really high quality libraries that just, that if we can kind of work to get them together, I think we will have a really first-class statistical environment. And so, yeah, I guess you could say, the art of coordinating multiple projects over Twitter in the age of GitHub is this kind of horrible problem. And that isn't to say anything bad about GitHub, but we do have this kind of tendency to create these tools, just kind of release them to the world as our own little domains, and don't really think about the ecosystem of our language. So yeah, and I think this is kind of my final pitch. I think it's really in our interest as Scala developers to promote the state of affairs with respect to hiring, the sanity of our own lives, and if we can really have this kind of next generation of people who are using Scala. And finally, that it's actually really able, this production thing that can be done well, right? We have the same abstractions for kind of working in small with our data as when we go out to our big Hadoop or Spark or whatever cluster. And I think it's really a chance to showcase off the intuitive clarity of higher mathematics and get some widespread adoption for some of these abstractions. So as in the talk, I really wanted to try and get together like a little Google group to kind of promote discussions and maybe some hacking projects, and to get some like prototypes out there of how these things can work together, because it's obviously not a trivial problem how this works out. It's completely non-trivial, but I think it's very much worth it. And yeah, as I said before, we're hiring inclusive, so come back.
How close do you think Scala notebooks, like visualization stuff, is to where you think it needs to be? I mean, it seems like that's sort of the weak piece of the puzzle, right?
Yeah. I mean, that's hard to say, right? Because you can incorporate it with like D3. You can just use D3, and D3 is nice. I think there's really something to be said about like the kind of grammar graphic style. I think I like D3 a lot. And it's absolutely perfect for the stuff that like Mike Bostock, its creator, does, right? These kind of one-off projects. But I really think this grammar graphics is really nice for the kind of data science workflow, right? You do have a kind of core. You want this kind of middle ground between D3 and Excel, right? You don't just want this chart library, but you want these sensible abstractions to say, I want this with this kind of fascinating, and maybe some color stuff. So I think it's a really nice step, and it's definitely the best solution that's out there now. I mean, yeah, even doing D3 by hand is better than anything. I think that's it.
So one quick data point to add to your list. There is a company doing our integration with Spark. So that would be a nice way of integrating that part of Scala.
Yeah, I've seen several things. There was some crazy things with like R implementations on the JVM even. And it was all these, I saw a lot of things recently. I haven't had a chance to really play with them. But yeah, I think being able to kind of outsource to someone that's maybe with a nice Scala wrapper on top would be very powerful.
So I don't know anything about this. I have a very ignorant question. What's the difference between this notion of a frame and just a list of some tuple type? What is it that a list of tuples doesn't give you as an abstraction?
I think having the index.
Well, okay.
Well, so one, you don't have the
That's
heterogeneously
cool.
typed, right? Because we want the columns, not necessarily just the right. Like we want to have for this experiment, we have all these different data points. They're different types, right? And we need columns that are differently typed. We need record types, and we want it to be indexed because you want to be able to easily just say, well, what's this for this for this? And I think the other thing that if doing this frame data structure works, as you mentioned, is because you want this frame structure that's fed into things, and obviously also when you're feeding into like some kind of statistical model, it's going to have to pull out at some point a matrix of numerical data, right? So you want a structure that it really works for this kind of experimentation phase with these great indexes and this really nice functional API. So you want it to be close to working with lists in Scala, right? But you want it to be fast indexed, heterogeneously typed, and have a really easy way to transform, implicitly into some kind of high performance matrix, right? So it's the indexing, the heterogeneous types, and how it integrates with this kind of high performance single types matrix.
When you talk about heterogeneity at like the element level, not just different columns having different types, but the column itself is uniform. But the case where the column is not uniform, do you primarily mean like different numeric types, or are you talking like some random string data mixed in, or like and if it's string data, are you talking about all the possible different sort of deserializations of that string data, or just the fact that it's string data? Like I guess the thing I'm not sure about because I don't know R very well is like. Are you imagining actually deserializing all your strings into like different weird case classes and stuff ahead of time, or are you imagining some kind of like deserialization framework where the data frame actually kind of does that for you, figures out what it is or something on the fly dynamically?
So I'm mostly interested in the case where it's Yeah, I mean, so you could have some kind of categorical variable. You could imagine having these kind of cases that are inhabiting this. Yeah, so I'm mostly interested in the case where it is kind of consistently typed on this same pattern. Maybe we do some pattern matching and just sorting. That's great.
I don't know anything about pandas, so what do I need to know to know what's viable about it that's missing from Scala?
Well, so pandas, I mean, immediately it's in Python, so it's very similar APIs, right? It's I don't want to seem like I'm being harsh on satellite. I think this heterogeneous type is a really serious problem, right? Just want to clear that. And in Python, you get that for free, right? Because you can just have heterogeneously typed things. You don't really have to compile it as a yell at you, right? So it immediately gets this heterogeneous case, and so it can express this kind of tidy data abstraction, and that's the main thing, right? And so part of our argument has to be that Python or Scala should be able to offer. We have the tools to provide that abstraction, this column, heterogeneously typed columns, and so we shouldn't have to just kind of resort to any at this point, but it will require some more.
That was a cultural question. So I noticed, like recently, especially in Scala days in New York, there was a bunch of financial companies moving into Scala. And I mean, from my previous observations, they're the busiest people, right? They watch the money like flowing by and all focused on that. And somehow, Scala companies find the time to actually produce also libraries like Data Mishka and some other stuff. So I'm just curious, what is it about this new batch of financial companies using Scala which makes these good libraries coming out? Like, is there sort of the culture where open source and reuse is encouraged? Do you find this is useful for the community? Like, how is it possible?
I mean, I can't speak to finance in general. I mean, again, I'm something like a data scientist, right? I mean, I never worked in finance or something before this, working for Pellucid, so I can't speak to that. I mean, I'm a Scala developer who cares about the tools that we have for working with data. I think it's a really important problem. I mean, we've just seen kind of serious impact cases before that things like Excel have had these kind of bad tools, lack of type safety, have really concrete impacts on the world, right? I think the tools we have for accessing data are really important and not things that should just be closed.